What is FETs? FETs is stand for field effect transistor. Each of FETs consists of two channel types, which is N-type and P-type. There are two major types of FETs, which is JFETs and MOSFETs. MOSFETs consist of depletion MOSFETs and enhancement MOSFETs. JFET, also known as junction gate field effect transistor, and one of the simplest types of field effect transistor. On the other hand, MOSFET, which stands for metal oxide semiconductor field effect transistor, a transistor and a semiconductor device is widely used for switching purposes and for the amplification of electronic signals in electronic devices. The basic operation of JFETs is exclusively voltage controlled, in that they do not need a biasing current. Electric charge flows through a semiconducting channel between source and drain terminals. Meanwhile, the basic operation of enhancement MOSFET is to induce the channel positive polarity of the gate to source voltage is required. A large amount of voltage must be applied at the terminal gate for this operation. If the voltage applied at the terminal gate to the source is zero, enhancement MOSFET doesn't count. This can be the reason it is initially in off condition. Depletion MOSFET are generally known as switch-on device, because these transistors are generally closed when there is no bias voltage at the gate terminal. If the gate voltage increase in positive, then the channel width increase in depletion mode.
Next, I will presenting on graph of JFET. JFET are divided into two, which is self-bias graph and voltage divider bias graph. First, I will share with you on self-bias graph. On first step, we will determine on VGS, ID, VDS, VS, VG, and VD. First step, draw the self-bias line, which is VGS equal to negative ID times with RS. When ID equal to 0, VGS equal to 0. Choosing ID equal to 4 mA, VGS equal to negative 4 mA times with 1 kilo ohm equal to negative 4 volt. The line is drawn below in figure. Step 2, we will see plot the Shockley equation and the data we took, which is IDSS equal to 8 mA, VP equal to negative 6 volt. With the formula ID equal to IDSS bracket 1 minus VGS over VP bracket power of 2, and we plot into the graph. Into the step 3, show the Shockley curve and the self-bias line on the same graph paper. From the graph, VGS equal to negative 2.6 volt, ID equal to 2.6 mA. From the Q point, we drag the line into the x-axis and y-axis to determine the VGS and ID. And the last step, find the remaining quantities, which is VDS, VS, VG, and also VD. For VDS, we use VDD minus ID times with RS plus RD, and the answer is 8.82 volt. For VS, ID times with RS, 2.6 mA times with 1 kilo ohm, and we get 2.6 volt. VG will remain 0 volt, and VD, we use VDS plus VS equal to 8.82 times VD, we use VDS times VD, we use VDS plus with VS, and 8.82 plus with 2.6 and get 11.42 volt. And the next, which is voltage divider bias. In the voltage divider bias, we will determine VG, ID, and VGS, VD and VS, VDS. For VG, we will times R1 with VDD divided with R1 plus R2 and get 2.16 volt. For IDSS, 10 milliampere and VP negative 3.5 volt with the formula ID equal to IDSS bracket 1 minus VGS over VP bracket power of 2 and VP negative. For VP we 10 times 10 power of negative 3 bracket 1 negative minus VGS over negative 4 power of 2. For the bias line, we use VGS equal VG minus ID RS times with RS. 2.16 minus ID bracket 1.1 kilo ohm. When ID is 0, VGS equal to 2.6 volt. When VGS equal to 0, I equal to 2.16 over 1.1 kilo. And we get 2 milliampere. From the graph, we see that IDQ equal to 3.3 milliampere. VGS equal to negative 1.5 volt. As we drag it down to the x-axis and y-axis. Lastly, VD equal to VDD minus ID times RD. And we get 12.74 volt. And last but not least, VS ID times with RS equal to 3.63 volt. That's all from me.
I'm Hua Jiamei, and now I will continue our presentation by showing one calculation example of JFET configurations. Now we can see here showing us a voltage divider circuit, and it gives us a 20 watt VDD, and the VD is 9 watts, and the IDSS is equal to 10 milliampere. And the DV is given us by 9 watts. The question asks us to determine the ID, VS, VDS, VG, VGS, and VP. And now I'll show how to calculate this. First, we want to find the ID. We use the formula of ID equal to VDD minus VD divided by RD. This is the same as the formula as I equal to V divided by R. Now we will get the answer of 5.5 milliampere. We just insert the VDD minus VD divided by RD, which is 2K, and we will get this answer. And next, we will find the VS. We use the formula of V equal to IR, which is VS is ID multiplied by RS. And we will get the answer of 3.74 watts. And now, you can see we have the VD and VS already, so we can easily find the VDS. VD is given by 9 watts and the VS is given by 3.74 watts. And we will get an answer of 5.26 watt. Next, we will find the VG. How do we find the VG? We use the voltage divider formula, which we have learned before. This is the VG equal to VDD, the total voltage times the R1 divided by R1 plus R2. And we'll get an answer of 2.164 volts. Next, by finding the VGS, we can easily get it because we have the VG and VS already. So we just insert the value of VG and VS into here, minus VS 3.74 watts, and we will get negative 1.576 watts. Next, we'll use the formula of ID, which is the ID equal to IDSS times 1 minus VGS divided by VP square. Square these two. And after that, we use this formula because we have the VP here. So we'll get an answer of 6.1 volts. As conclusion, we can easily calculate this by using this few formula. So that's all from me.